Hi there everyone, and welcome to today's session on equations and inequalities. I'm Melissa, the in-house maths teacher here at ICS Learn, and if you need to contact me anytime, I know I say this at the start of every single webinar, but please don't hesitate. It's my job to help you with your maths as well as your tutor. You can call me direct on the phone number that you can see on your screen there, or email me mathsteacher@icslearn.co.uk. So today we're going to have a look at how to solve certain types of equations and also inequalities. Now I'll say here these are the easier types of equations because later on in the course we're also going to do quadratic equations and simultaneous equations, both of which are new to foundation tier, so everybody has to do them regardless of what tier you're doing. And we'll look at examples today involving brackets and where you've got terms on both sides of the equal sign, also where you have to write equations from given information. And we'll also take a quick look at some inequalities which are solved in a very similar way with one particular exception which I'm going to explain here. Please make sure that you watch lesson 10 first. So lesson 10, if you haven't watched it already, is where I introduce equations and how they're solved. So I'm really going to build on the information which I gave in lesson 10. So if you haven't watched lesson 10 already, here is a link to it. This is a link to the YouTube version, but you can also watch the WebEx version of this just by scrolling to the very bottom of your GCSE 9-to-1 Math Lessons page. If you are watching the recording of this and you can't see that link in the chat box, then you might need to open the chat box up, click on View, select chat, and that will open up the chat box, and then you can click on all the links that I'm pasting in the chat box. If you're watching the YouTube version of this recording, go to the box underneath the YouTube video and you'll see a description box underneath it. Click where it says show more, and I'll paste all of the links into there so you can get them afterwards. Please do make notes as you watch, as always. The content of today's lesson corresponds to section 7 in unit 2 in your main course materials, but you won't be able to see those materials until you've completed test paper 1. So although you can watch this lesson, you can work through the materials in your textbook, you just won't be able to work through these particular activities until you've completed test paper 1 and your tutor has marked it. If you're having any problems finding test paper 1 or completing it, it's quite a straightforward test. It only assesses you on the topics in the first study unit, so most people should be able to do it. You might even be able to do it straight away before you've even worked through unit 1, so have a look at that if you can. And once you've done test paper 1 and you want to try these exercises, there's objectives and little boxes that you can fill in. Section 7 on equations, formulae and inequalities. It's just in there, so there's a link for you, so that you can just go straight to this section. Use your textbooks as well. So in your textbooks, you've got an overview of each topic and worked examples. So if you need more worked examples, have a look in the textbook. If you're using the foundation tier version of the textbook, it's chapter 14. Just do the first section, which is linear equations, which is what I'm doing today. So don't worry about quadratic equations for now. Don't worry about simultaneous equations for now. Just focus on linear equations. We'll do those first, and then we'll go back to the harder ones later on. So if you're working through the foundation tier textbook, section 1 on linear equations is in chapter 14. There's a lot of bombarding you with the links at this stage, so if you want to have a look at the worked examples and explanations in there, do have a look. If you're working on the higher tier version of the book, linear equations, very similar, but it might have some more difficult examples. So if you want some more challenging examples, that would be chapter 15 in the higher tier book. There's a link to chapter 15, so you can try that in the higher tier, and that will just link straight to the beginning of the chapter. Inequalities in the foundation tier book is covered in chapter 34. Now we've done a little bit of inequalities before. We looked at inequalities in the number line, but today we're going to look at solving inequalities. So if you're working on the foundation tier book, chapter 34 is here. There is a link to you can ignore the bits that we've done already, just go straight to the bit about solving inequalities. And then higher tier, chapter 36. Now for higher tier, you also need to know how to plot inequalities on a graph to get regions. But don't worry too much about that for now, because we'll go on to that in unit 4 when we start covering the topics that are only at higher tier. So you can leave those bits out for now if you're doing higher tier, unless you want to cover them straight away. You can. I'm not going to stop you from moving ahead, and you can even do the unit 4 lessons right now if you want to. They're all there as recordings. Okay then. So The only thing I'm not going to cover in this session is equations involving fractions. I just couldn't fit it all into one session. So what I'm going to try and cover today in the 1 hour is equations with brackets. So make sure that you've watched the previous lesson that I did on brackets and factorization, because you need to be confident with multiplying out brackets. We'll look at equations with the unknown, the letter on both sides. Negative coefficients, don't be scared by the word coefficients. The coefficient is just the number that is in front of the unknown, in front of the letter. And we'll look at how to write equations to solve problems. These come up a lot and people do get stuck with them quite often. They usually involve geometry or where you're given some information and you need to make it into an equation and then solve the equation to solve the problem. And then we'll take a quick look at solving inequalities at the end. And inequalities with negative coefficients, which work in a similar way with one important rule, which we should learn. Okie dokie then. Now, you should remember from lesson 10 that we think of an equation. The word equation means equal, and we think of it as a balancing act. We've got the equals in the middle. So when we talk about left-hand side and right-hand side, we're talking about the left-hand side of the equal sign and the right-hand side of the equal sign with the equals in the middle. And then what we do to solve an equation is we just follow this one golden rule, and that is to do the same thing to both sides, and then it will still stay in balance. So if I think of it as a pair of scales and I subtract 3 from both sides, they both become 3 lighter. And if I add 10 to both sides, both become 10 heavier, and they're still equal. If I double both sides, they're both the same weight. If I divide both sides by 3, if I half both sides, they're still the same. So as long as I do the same thing to both sides, the equation will still be a true statement. And what you want to do is manipulate the equation until you just have it in the form x equals a number. Now, it could be x or it could be any letter, but what we want is just that letter on its own. So we might have to take things away from it, we might have to divide it by things, we might have to multiply it by things. So depending on what's been done to that number, we need to undo those things to get the letter on its own. Whatever we do to that side of the equation to get that letter on its own, we need to do to the other side of the equation. And that way we can find out what that letter is worth. And then always at the very last step, take the value that you get, substitute it into the original equation just to make sure that that gives you a true statement. And that's what solving an equation means. It means finding the value of that letter that makes the original statement true. So let's have a look. So we're trying to get a letter equals a number. And you can swap sides. You're allowed to do that in algebra as well. So if you have it so that you've got a number equals a letter, you just swap them round at the end. So for example, if you have x equals 3, it just means that x has the value 3, and that's called the solution to the equation. Now remember that to get rid of something, so if you've got a minus 5 and you don't want it and you want to get rid of it, you just add 5. If you've got multiplied by 3 and you want to get rid of it, you divide by 3 and so on. So remember that plus is the opposite of minus and that minus is the opposite of plus. So we're undoing what's been done to get the letter on its own. Also, multiplication is the opposite of division, and division is the opposite of multiplication. And remember in algebra that multiplication signs are not always written. So if you have something like 3x, that means 3 times x. So the multiplication sign is left out. 3x just means 3 times x. So if you want x on its own, you need to divide by 3 to get the x by itself. And similarly, the division sign is not used. If you have x over 7, like a fraction like this, let me just write it out for you. So if you had something like x over 7, like a fraction, that means x divided by 7. So if you wanted to get rid of the 7 on the bottom, you would multiply by 7. If I multiply that by 7, that just gives me x. X divided by 7 times 7 is just x. Okay, so we need to get quite good at this, and practice is the key thing, just lots and lots of practice. So here we have an example. This is similar to one of the ones that we met in lesson 10. And we want to solve the equation 4x minus 3 equals 17. So that means 4 times a number, the number I'm trying to find the value of, take away 3 equals 17. Now you maybe could work this out in your head, but it's important to go through the method. Just for more complex examples later on, you need to know how to work them out. So we're trying to get this x on its own. So what's been done to this x? It's been multiplied by 3. It's been multiplied by 4, and then 3 has been subtracted from it. So what we're going to do first is add something to both sides to get rid of the minus 3. So what do you think we're going to do to get rid of the minus 3? Let me know. So I'm trying to get rid of this minus 3. What should we do? Gemma, thinks add 3, Thomas thinks add 3. Okay, let's see what happens. So if I've got minus 3 and I add 3, that just gives me 0. So I add 3 to both sides, and that keeps my equation in balance. So on the left-hand side of the equal sign, I just have 4x, and on the right-hand side, I have 20. So 17 plus 3 is 20. Does that make sense? Kind of makes sense, because if you think what I'm saying in this statement is that 4x is equal to 20, and that makes sense, because if 4x is 20, then what I'm saying is 20 minus 3 equals 17. So that's certainly a true statement, 4x is 20, because that would make that true. And one method that some people use is what they call a cover-up method. So you could just cover up the 4x, put your finger over the 4x and say, what's the missing thing? So what take away 3 gives me 17? Well, 20 take away 3 gives me 17, so 4x must be 20. And then to get the x on its own, what's happened here on the left-hand side is I've got 4 times x. So how do I undo multiplication? How do I undo 4 times something? Some people are putting the answer, which is fine. You could do that in your head, actually, because I'm saying 4 times something equals 20. So 4 times 5 equals 20. So you could do it that way and say, well, I know that the x must be 5 because 4 times 5 equals 20. Or you could do 20 divided by 4. So you could divide both sides by 4, doing the same thing to both sides. You don't need to write this step down. You can just do it in your head. So anything that I'm showing in blue here is something that you can do mentally. You don't actually need to write this down unless it helps you. When you're just getting started, just to make sure that you don't make mistakes, it might be easier to put that step in. If not, just do it mentally with practice. So divide both sides by 4. 4x divided by 4 is just x. And then 20 divided by 4 is 5. So there, nice easy one to get us started, x equals 5. And then check that that works. So go back to your original equation, check that 4 times 5 is 20, take away 3 is 17. So it does work, it gives me the number that I started with. So it's always a good idea to check that that answer gives you the right solution in the original equation. Okay, now here's one with brackets. Now there's actually 2 ways to do this one. I could divide both sides by 3 in the first step. So if I divided both sides by 3, I would have h minus 4 on the left-hand side, and then 7 on the right-hand side. So I could do it that way. Alternatively, and this is probably the better thing because this always works, even if the 2 things don't divide, multiply out the bracket. So multiply out the bracket and then just solve it as a normal equation. Remember how to multiply out brackets? So remember that there's a 3 in front of the bracket, multiplies the 2 things there inside the bracket. So this means 3 times h, which is 3h, and then 3 times minus 4, which is minus 12. So what it means is h minus 4 plus h minus 4 plus h minus 4. I'm multiplying both things in the bracket, and then that's equal to 21. So when I multiply out the bracket, always line up the equal signs, by the way. Multiply out the bracket, I get 3h minus 12 equals 21. How do I get rid of the minus 12 is the next thing I need to ask myself. I don't want that there because I just want h on its own. I need to add 12. So add 12 to both sides. And that way on the left-hand side, I've got minus 12 plus 12, so that disappears. And then on the right-hand side, I've got 21 plus 12. Now, some people remember it as change the side and change the sign. You can do it that way, but it won't work for all types of equations. When we do more difficult equations later on, things like quadratic equations, that change the side and change the sign won't always work. So it's better to think of it as doing the same thing to both sides. So let's have a look. We've got some different answers coming up. So let's see. Don't try to do too many steps at once. With these multi-step equations, it's better to do it bit by bit. So if we add 12 to both sides, we've got 3h on the left-hand side. And 21 plus 12 is 33. So we've got 3h equals 33. The last step should be quite easy because this is just saying 3 times what equals 33. Or you can just divide both sides by 3 to get the h on its own. So divide both sides by 3 and we get h equals 11. So everyone that put h equals 11, Summer and Gemma, yeah, some dropped your way down to twice. Jake, you got there, and Summer, you're right, but then you changed it. Okay, h equals 11. Let's take a look at what would have happened if we'd done it the other way. If we divided both sides by 3 in the first step, then I would have had this divide by 3 and this divide by 3, which would have given me h minus 4. Often in algebra, there's more than one way of getting the same answer, which is equal to 7. And then add 4 to both sides, h equals 11. So if I'd done it that way, I would have got the same answer in fewer steps, and I wouldn't have had to multiply that bracket. But sometimes you won't get something that divides through both sides exactly. So just make the decision based on what the equation is for the best way to solve it. Always check that that works by putting it back into the original equation. So if h was 11, then I would have 11 minus 4, which is 7. And remember, the 3 in front of the bracket just means 3, oops, I'm writing 7 because I just said 7. That means 3 times 7. So 3 times 7 equals 21. So that works, that's correct. The number in front of the bracket multiplies what's inside the bracket. Perfect. Okay. You'll just have to practice lots of those because I haven't got time to go through lots and lots of examples. So basically, if you see an equation with brackets, multiply out the bracket and then solve the equation as usual. Now, when we have the letter term on both sides, you still do it in exactly the same way, but we need to have all of the letters on the left-hand side usually, and all of the numbers on the right. So suppose we've got something like 4m minus 3 is equal to 3m plus 2. Now, we don't want to see m twice, we just want to see m once. So what we're going to do is take away, so remember we want letter on this side, letters on that side, and numbers on this side. By numbers I mean numbers that are on their own. My handwriting is going a bit wibbly. So what we want to do is get rid of this 3m because we don't want an m on the right hand side. So to get rid of 3m, we just subtract 3m. If we subtract 3m from the right hand side, then we have to subtract 3m from the left hand side. You could sort out the numbers first as well. It doesn't make any difference. It will work either way. So I think that's what I did here. So you can either subtract 3m from both sides in the first step, or if we want to get rid of this minus 3 here, because again, we don't want any numbers on their own on the left hand side. We want the numbers on their own on the right hand side. So to get rid of that minus 3, we need to add 3 to both sides. So if we add 3 to both sides, these cancel out because minus 3 plus 3 is just nothing. And then on this side, I've got 2 plus 3, which is 5. So that leaves me with 4m equals 3m plus 5. Always line up the equal sign. And then I want my m's on the left-hand side. So now I'm going to subtract 3m from both sides. If I subtract 3m from this side, it gives me 0. And then I have to subtract 3m from that side. What's 4m take away 3m? 4m take away 3m. Someone's put in the answer already. 4m take away 3m is just m. Because remember, we don't write 1 in algebra, so we just write m. It just means 1m. There's a kind of an invisible 1 there. And then these 3m's obviously just cancel out. That's what we wanted. And that leaves me then with 5 at the end. So m equals 5. Who got that? Jake. And Gemma and Sam, I know you're answering my question. 4m take away 3m is just m. Well remembered. We don't need the 1 at the beginning, so m equals 5. Check that both sides are equal. It's a little bit more difficult here because there's more things involved, but check that if you substitute it back into the original equation, you get an equal statement. So if m is 5, 4 times 5 is 20. Take away 3 is 17. And then on the right hand side, we've got 3 times 5, which is 15. Oh, sorry. I was going to put a plus instead of an equals. 15 plus 2. 20 take away 3 is 17, and 15 plus 2 is 17, so that's a true statement. So that's the value of the letter that makes that statement true. Perfect. If we'd done it the other way, if we subtracted 3m in the first step, that would have worked as well. So if I take away 3m from both sides, I would have ended up with m minus 3, so you might have done it like this, is equal to, I've subtracted 3m, so I'm just left with 2 here. And then to get our m on its own, I need to add 3 to both sides. M equals 5. So you could have done it that way as well. And I'm doing the steps where I'm doing the same thing to both sides in my head, and that gives me the answer there. Happy with that? It'll just take a lot of practice. So if you're someone that finds this really hard, you just have to do lots and lots of practice. If you want extra practice questions, let me know, and I've got loads of worksheets. If you want just drill questions where you're just going through the same thing, I can give you more questions if you want to. Okay, here's another example with the letter on both sides. So this time we've got 7b minus 8 equals 2b plus 12. So we want to find the value of b that makes this true, this statement true. So let's start by adding 8 to both sides. You could also subtract 2b from both sides. That would work as well. So if we add 8 to both sides, so remember we don't want this plus 8, this minus 8 here. So we're going to add it to the other side to get rid of it on that side. So that will leave me. Yeah, Elaine, if you email me and I'll send you a worksheet with loads and loads of equations on it. I think it's the best way to learn algebra. It's what I did when I was at school. We just got this big textbook and we just had to work through hundreds of equations. It's quite therapeutic. You just zone out and you just answer lots and lots of equations. It really is the best way to learn algebra. So if we add 8 to both sides, we get 7b equals 2b plus 20. And we don't want the letter on this side, so we don't want those. So we're going to subtract 2b from both sides. And that will just give me 20 on its own on the right hand side. 7b minus 2b is, well, 7 take away 2 is 5. So I've got 5b equals 20. And these just cancel out, which is what I wanted. I chose that value so it would cancel out. So I've got 5b equals 20. And then you know that 5 times 4 is 20. Sometimes it can involve fractions, in which case you would just divide both sides by the same thing. So that's why it's easier to remember the rule about dividing both sides by the same thing, because sometimes we get a fraction value at the end. Divide both sides by 5. 20 divided by 5 is 4. So b equals 4. So well done, Jake, on your second attempt, and Summer and Ahmed and Violet. Well done. Let's check that that works. So if b is 4, then we've got 7 times 4, which is 28. So 28 minus 8 on that side, and that gives us 20 on that side. And is that equal to 2 times 4 is 8 plus 12? Well, that's also 20. So we got it right. Of course we got it right. Now sometimes the number in front of the x is negative, and that makes things a little bit trickier. There's two ways that this might end up. You might end up with a negative number, in which case you just have to divide through by -1, or you might end up with the unknown on the other side, and then you'll have to swap it around at the end. Just needs an extra step. So it's all about just being confident about how these work. The same rule applies to the same thing to both sides until you get the letter on its own. So supposing we had a number or term like this. So here's an example of some numbers. This is just to show you what the word coefficient means. So if I have 3x, what is the coefficient of 3x? Type it on the screen and we'll have a look. So it's the perfect, Ahmed, well done. Jake, yes. It's just the number that's in front of the letter. So the coefficient of 3x is 3. How about 7a squared? What's the coefficient for 7a squared? Thank you, Jake. Yeah, it's quite easy. The coefficient of a squared is 7. How about minus r? If I've got minus r, what's the coefficient of r? Any idea? It's not 1, but you're close. So if I've got negative r, what's the coefficient of r? Well done, Summer. Good. It's actually -1. So if we have minus r, it means that the number in front of the r is -1. And how about the last one, -7ab squared? What's the coefficient there? Yeah, so the minus sign is, if it was just r, then the coefficient would be 1, but if it's minus r, the coefficient is -1. Yeah, easy. Well done, everyone. Violet and Hussein, Flavia and Summer. Gemma, brilliant. That's a nice, easy question there. The coefficient of ab squared is -7. If you're doing foundations here, you probably won't ever hear about coefficients again, but for higher tier students, coefficients will come up quite a lot, because you need to be very good at algebra if you're doing higher tier. So here's an example of an equation with a negative coefficient. So it's got a negative number in front of it, so we might just need an extra step to work it out. I've made it quite easy by not putting another number in front of the g there. I've just said 13 minus g is 6. You can maybe even just do that in your head. 13 take away what gives me 6 as an answer. 7, I think. Yeah, perfect. All right, but if we're going to solve it as an equation, let's just look at the steps for an easy example, and then we can apply it for harder examples later on. So there's two ways to do this. You can either start by adding g to both sides just to get rid of the negative number. So if you don't like dealing with negatives, we could just add g to both sides, and then that will get rid of that minus g and it will give me a plus g instead. So if I add g to both sides, that will give me 13 on the left and 6 plus g on the right. And I just want g on its own, so then I subtract 6 from both sides. Subtract 6 from both sides, 13, take away 6 is 7. So I'm left with 7 equals g. And that just means g equals 7. So in the last step, you can just swap them around like this, g equals 7. Another way that you could solve an equation like this is to start by subtracting 13 from both sides. You're going to end up with some negative numbers. As long as you're confident with negative numbers, you could do it this way. But remember that the minus sign still stays in front of the g. So if I subtract 13 from both sides, then I would get minus g equals 6 subtract 13. 6 subtract 13 is minus 7. So I've got minus g equals minus 7. So to get the g on its own, I need to multiply both sides by minus 1. So all I do is change the sign. So minus g times minus 1 is just g. And then minus 7 times minus 1 is just 7. So it gives me the same answer, but it's a little bit more difficult because I've got to deal with negative numbers. Just whichever way you find easiest. Both work and both give me the right answer. Okay, here's another little slightly more difficult one. This time we've got letters on both sides of the equation, and both of them have got negative coefficients, so both of them have got negative numbers in front of them, so it's going to be a little bit trickier. What should we do? Should we sort out the numbers first or the letters first? I can't remember what I did in the example. So what I've done is I've added 6k to both sides. By adding 6k to both sides, I'm getting rid of the 6k here and putting all of the k's on the left-hand side, and that's absolutely fine. You can do it that way. So if I add 6k to both sides, here I've got minus 2k plus 6k. Remember, that means the same as 6k minus 2k, which is 4k. So on the left-hand side, I will have 8 plus 4k, and then on the right-hand side, I'll have 17 and then 0, because those two values cancel each other out, so we've just got 17 on that side. Is that okay? So that gives me 8 plus 4k. Is everyone happy with this step, that minus 2k plus 6k? You need to be very good with plus and negative numbers when you're doing algebra. And then 17. Yes, Ahmed, good. And then subtract 8 from both sides. So I want 4k on its own. So the next step will be to subtract 8 from both sides. So 17 take away 8 is 9. So I've got that 4k equals 9. Now this shouldn't worry you. It just means, so 9 is not exactly divisible by 4. That's absolutely fine. It'll just end up with a fraction. No problem with that. So sometimes equations do end up with fractional answers. Don't let that worry you. Just solve it in exactly the same way. Divide both sides by 4. 4k divided by 4, it just gives me the k on its own. And then 9 divided by 4 on the right-hand side is the answer. And you can just leave it like that. You could just say k equals 9 over 4. You could write it as a decimal if you wanted to. Ahmed, you've done that, 2.25, perfect. Or you could write it as a mixed number, 2 1/4. So if we did 9 divided by 4 is 2 and 1 left over, so we could write it as 2 1/4 like that, or 2.25. They're all equivalent. If you want to make life easier for yourself, just leave it as 9 over 4. You would still get full marks unless the question specified leave your answer as a decimal. You could just leave it as a top-heavy fraction like that. That's absolutely fine. Okay, that's quite a tricky one. Okay, let's move on to actually writing equations to solve problems in maths. Now the main thing is to read the questions very carefully. The hardest ones probably involve ages. Now sometimes you'll get something like Martha is 3 times older than her daughter, and in 5 years she'll be double the age of her daughter, and how old is her daughter now, that sort of thing. But those are a bit of a mind tangler, especially if you're dealing with two times now and in the future. But more often you won't get questions like that in the exam. Usually, I've never seen an age problem in the exam because they can cause confusion. More often it will be used to solve problems in geometry, for example, areas of rectangles or missing angles on a straight line, that sort of thing, where you're using letters to represent unknowns and then writing an equation and then solving that equation to find the answer. Okay, let's have a look at a few examples. This is a quite straightforward one. In fact, I think I used examples like this to introduce solving equations right at the beginning of lesson 10. So this just says Kirsty thinks of a number, she doubles it and adds 5, and the result equals 19. What number is she thinking of? So we want to write this as an equation. Let's just call the number that Kirsty is thinking of. I think, Gemma, you're saying that she's thinking of 7. Yeah, good. You've just undone what's been done. So you started with 19, subtracted 5, and then halved it to get the answer. You can do it that way if you want to, but it doesn't always work for more complicated ones. So let Kirsty's number be k. So the thing that you're trying to find, always call that by the letter. And then what's she doing? She's doubling it. So double k means 2k and adds 5. So 2k plus 5. And the result is 19, so equals 19. So it's a little bit like translating the words into symbols. So altogether we've got 2k plus 5 equals 19, and then we can solve it. subtract 5 from both sides, just in the same way as we did before, 2k plus 14. Then, because this is 2k and we just want k on its own, we divide both sides by 2. That gives me k equals 7. So everyone that said 7, well done. Make sure it works. Double from this 14. 14 plus 5 is 19. So we got it. All right, I'm just starting with an easy one. Here is a slightly more difficult one. So it's not too difficult. Here we're told that Joe is 3 times the age of his son Michael, and he's also 24 years older than Michael. So this is quite an easy age one because we're not dealing with what's going to happen in 5 years or anything like that. How old is Michael? So the first step is to not panic. Just say, okay, what am I trying to find? I'm trying to find Michael's age. So first of all, we always use that in algebra. Let Michael's age be m or something like that, or some letter. It could be x or n or anything like that. So let's use m for Michael. So Michael's age is m, and then we're told that Joe is 3 times the age of his son Michael. So that would be 3m, and he's also 24. So this is where our equation comes into it. So Joe is 3 times the age of his son Michael, 3m, and he is also m plus 24. So then we can equate those two things because I know they both come to the same number. We don't actually need to know how old Joe is. We just need to know that we've been given Joe's age in 2 different forms, 3m and m plus 24. So we use those two things to make our equation. Does that make sense? So sometimes you've just got to think a little bit about what we're being told. So we make those two things equal. So 3m equals m plus 24, and then it's dead easy to solve. Subtract m from both sides. So we get 2m equals 24. Not sure though. Well, let's have a look. 2m equals 24, and then divide both sides by 2. M equals 12. Can you see how I got that? Not sure why a. And well, let's check that that works. So Joe's 3 times the age of his son Michael. 3 times 12 is 36. So he must have been 24 when he was born. And then he's also 24 years older than Michael. So 12 plus 24 also equals 36. So in other words, Michael's 12 and Joe is 36. So certainly there's enough information there to find out how old Michael is without even needing to work out how old Joe is. Or you just guessed it. Always better to use algebra just to make absolutely sure. Is everyone happy with this? So this is 3 times Michael's age. This is Michael's age plus 24. And then I know that I'm getting the right answer. So that, in that way, algebra is very useful for solving problems like this. Lots of different problems are solved through algebra. Okay, now probably in the exam there will be a question that will involve geometry in some way. So geometry as in problems involving angles. It might be a parallelogram with some of the angles given. You've got to remember your rules about opposite angles in a parallelogram are equal. It might be an area problem where you're told the area of a rectangle, but then you're told that the lengths of the sides are 3x plus 2 and things like that, and then you need to write an equation. So multiply the length by the breadth, get some brackets, get some x terms in there, and then solve it to find the value of x. So this one involves angles. Now, you should remember from lessons that we've done before that the sum of the angles on a straight line are 180 degrees. In the exam, they probably won't tell you that fact. You just have to know that. Given 3 angles in the diagram, find the value of x. So what would we do if these terms were numbers? Well, we would just add them together and make them equal to 180. So we start like that. We say 3x, this angle, plus 2x plus 40 plus 5x equals 180. And that's our equation. Then we just solve it in the normal way. Everyone happy with that? The next thing that we need to do is collect together like terms. So we're going to collect together all of the x's. So if we've got 3x plus 2x plus 5x, 3 plus 2 is 5, and another 5 is 10x. Thank you, Jake. That is correct. So let's do that first. Let's not do too many things at once. We could subtract 40 from the other side, but let's just do it step by step. So collecting together all of the x's, we've got 10x plus 40 equals 180. Next step, we want x on its own, so we're going to subtract 40 from both sides. So if we subtract 40 from both sides, 180, take away 40 is 140. So we've got 10x equals 140. Jake, brilliant. and then divide both sides by 10 to get x on its own. So x is equal to 14. And how do we check that that's right? Well, we could just go back to our original equation. You might have to help me out here. I'm not very good at multiplying in my head. So if x is 14, I might even have put it in here. X is 14. Yes, I did, because I knew I wouldn't be able to remember how to do it. So if we filled in the missing numbers, 3 times 14, you can probably do that in your head. 3 times 4 is 12. 3 times 10 is 30. 30 plus 12 is 42. So 3 times 14 is 42. And then in this section, we've got 2x. 2 times 14 is 28. 28 plus 40 is 68. And then in the last one, we've got 5 times 14, which is the same as 10 times half of 14, which is 70. Then if we add these together, 42 plus 28 is 70. Plus 70 is 140. Plus another 40 gives me 180. Perfect. Okay, got that. So it's always a good idea just to check at the end, just to make sure that it gives me the right answer. There we go. Okay, let's have a look at solving inequalities. Now, when we solve inequalities, we want to find values of x that make the statement true. It works in a very similar way to equations, except that remember that we're getting a whole range of solutions. So supposing we're given this statement, x plus 4 is greater than 7. So any value of x that makes that true will be a solution to that statement, to that inequality. So if x was 10, I would have 10 plus 4, which is 14, which is bigger than 7, so 10 works. How about 3? 3 plus 4 is 7. Is 7 bigger than 7? No, it's not. So 3 doesn't actually quite work, but anything bigger than 3 would work. So in other words, any number bigger than 3, so any value of x bigger than 3, will make this inequality true. So that's what I say in my answer. X is greater than 3 will be the solution. And the way that I solve this, don't really need to overthink it, just solve it exactly the same way as an equation by doing the same thing to both sides. And the solution will be also be an inequality, and the symbol stays as it is. So if I've got x plus 4 is greater than 7, I can just start by subtracting 4 from both sides, and that will just give me x is greater than 3. So any value of x greater than 3 will make that true. So you don't need to think of it at all beyond that. If you were asked to show that solution on a number line, you could do it like this. You could draw a number line like that. They would probably print it on the exam paper. And then you might have 0. You might need to go back and watch lesson 10 if you've forgotten how to do this. So if you wanted to show that on your number line, 3, 4, it could go on up to whatever, 5. Now, it doesn't include 3, so I need to do an open circle at 3 like that. And then it's any value of x greater than 3, so it would just be a line. Remember doing these? Like that. And that would be my solution to that inequality. Here's another example. So we're just going to solve it exactly like an equation, except that instead of an equal sign, we've got this greater than or equal to symbol in the middle. So 3x minus 5 is greater than or equal to 16. So start by writing it down. Again, we're going to keep the symbol lined up. We want to get rid of the minus 5 from the left-hand side, so we've just got the x's on their own. So to get rid of minus 5, I need to add 5. Add 5 to both sides. I have 3x on the left. 16 plus 5 is 21. So 3x is greater than or equal to 21. Then divide both sides by 3 to get the x on its own. Anyone? Yeah, good. Divide both sides by 3. X is greater than or equal to 7. So if x was, let's just test it. So if x was 8, we would have 3 times 8, which is 24, and 24 take away 5 is 19. Yeah, and 19 is greater than or equal to 16. But if x was anything less than 7, so for example, if x was 6, we would have 3 times 6, which is 18, and then 18 take away 5 is it 13? my brain's getting tired. I can never do arithmetic in my head. Sorry, I've forgotten now. But that is, what did I say? 3 times 6 is 18, And 18 take away 5 is 13, and 13 is not greater than 16. So if there's any value of x that's less than 7, it's not going to work. And if it's exactly equal to 7, that works as well, because this is greater than or equal to. So if x was 7, 3 times 7 is 21, and 21 take away 5 is 16. 16 is equal to 16, so that also works. You get the idea, but you don't really need to overthink it, just treat it like an equation. But be aware that it's a range of symbols. Just don't accidentally put an equal sign in the middle. So I'm underlining that, I'm not trying to do an equal. Just make sure that, I can think of a better way of doing that, just make sure that the symbol in the answer is the same as the symbol in the question. Okay, that's the thing to remember. There's another thing about inequalities that you should know. I'm not sure if this will come up. I'll show you in a minute. It might not come up at foundations here, but I'll show it to you just in case. Now, if you have the inequality, now remember when we had equations and we had 3 equals x, and then we just swapped it around and had x equals 3. With inequalities, you need to be a bit careful with that, because when you swap the side, you've also got to swap the symbol in the middle. So if we had it this way round, if we had 28 less than or equal to 5x plus 8, we just solved it in our normal way. So I would probably start by subtracting 8 from both sides to get the x on its own. So I would have 20 is less than or equal to 5x. Then divide both sides by 5 because I want to get the x on its own. That leaves me with 4 is less than or equal to x. Now, if I want the x first, which is the way I would normally do it, and I want to swap these two sides around, this is telling me that 4 is less than or equal to x. So if I swap it round and I put the x here, oops, I still need to have the greater than side facing the x, so I need to swap the symbol around like that. So just remember that when you swap it round, you need to also flip around the sign in the middle. Does that make sense? Couldn't you just substitute the x by a number equal to 28 in the first place? I'm trying to figure out what you mean by that. I'm not really sure what you mean by substitute the x by a number equal to 28. I don't know. Substitute the x. Sorry. 5 times 4. So you're thinking, just think of the value of x that makes that true. So I suppose you could solve it like an equation, but you just need to remember what way around the sign goes. So if you solved it like in an equation, how would you know what way around the sign goes at the end? Yeah, I do know what you mean. So you could say, well, I know that if x was 4, then that would be x equals to 4. But then it's a little bit trickier to figure out what way around the symbol needs to go in. So the symbol has to be the same, but here the symbol's the other way around just because the x is on the other side. So do you see what I mean? So I would go through the steps formally like that, just to make sure that in the answer you've got the sign the right way around. This would be incorrect, because you need to have the greater than or equal to sign in between for it to be the answer to an inequality. Does that make sense? So of course you could work it out in your head if it was an equation, but you need to be a bit more careful with inequalities, that's all. Okay, practice them and you'll see what I mean. But that's just a rule that I want you to remember, and that is if you swap the x and the number around, you also need to swap the direction of the sign so it goes the other way around, so that this small end stays next to the 4. When you swap it around, it will stay the same way, like that. Okay, maybe it's neater. Now that I've shown it to you printed, you can see what I've done. So I've swapped the sides and changed the inequality symbol the other way around, like that. Okay, here's another one, and this time we've got unknowns on both sides. Just solve it like an equation, but keep the sign as an inequality sign, match the way it's written in the question. So here we've got 7x plus 3 is less than 5x minus 6. If we take away 5x from both sides, just to get all of the x's on the left-hand side there, take away 5x from both sides, we have 7x minus 5x, which is 2x, plus 3 stays where it is. So I have 2x plus 3, and then these 5x minus 5x is just leaves me with the minus 6. Don't forget the minus sign in front, that stays in front of the number. Then the next step will be to subtract 3 from both sides, because I just want the x on its own. So subtract 3 from both sides. minus 6, take away 3 is minus 9. So I'm going to have 2x is less than minus 9. And then the last step, divide both sides by 2. Don't let it worry you that it's a fraction. If 9 is not exactly divisible by 2, just leave it as 9 over 2. In some ways it's even easier because I don't even need to work anything out, just write it like that. If you want to write it as minus 4.5 you can, or just leave it like this, x equals minus 9 over 2. You could also write it as minus 4.5. Or just leave it like this, just leave it as x equals minus 9 over 2. It doesn't really matter whether the minus sign is in front or next to the 9. Happy with that? Sorry, I've made a mistake. Can you see what my mistake is? I put equals, but it's not an equation, it's an inequality. So do make sure that you leave the same symbol in the answer as the symbol you were given in the question. Doesn't the negative become positive? If we're dividing a negative number by a positive number, it's still negative. The only time when the sign changes is when we're dividing a negative by a negative. But otherwise, dividing by a positive number doesn't have any effect on the number, it just stays with the same sign. Does that make sense? So if I've got minus 9 divided by 2, it's just minus 4.5. Minus 6 minus 3? No, because if I've got minus 6 and I take away another 3, that takes me to minus 9. So revise positive and negative numbers. So imagine, for example, that it was minus 6 degrees and it got 3 degrees colder, then I would just go backwards down the number line and that would give me minus 9. So be very careful with signs. When you're adding and subtracting positive and negative numbers, you can have a negative number subtract a negative number, will just give me another negative number. Where you combine the signs with adding and subtracting is if we subtract a negative number. So if I had 2 subtract negative 5, that would be 2 plus 5. But you can't predict the sign when you're adding and subtracting. So if you're not sure about those rules for adding and subtracting negative numbers, maybe revise them. Okay with that? Minus 6 minus 3 is minus 9. Okay, yeah. Happy with that? I purposely am including examples with positive and negative numbers because it's important that you know these and revise them. It comes up all the time in algebra. Okay then, are you happy with that? Okay. I think the easiest way to think of positive and negative numbers when you're when you're adding and subtracting is to think of temperatures, because that gives you the, because you can think of colder as going down the number line and hotter as going up the number line. So I always think of temperatures if I'm not sure. Now, this is maybe beyond the scope of people doing foundation tier. I'm not absolutely sure, it might come up, so I can't guarantee that it won't. So I'm going to tell it to you anyway. Where you have to be very careful with solving inequalities. On the whole, they do work exactly like equations, except that you can't multiply and divide both sides by a negative number. It just doesn't work. If you do, so you can, but if you do, you have to change the direction of the inequality symbol. Sorry, Jake, different signs add up. Different signs you add up. The same signs you take away and leave the same symbol. Yeah, with adding and subtracting positive and negative numbers, you can never know exactly what the final answer is going to be. Except if you start with, if you've got a positive number plus a positive number, obviously the answer is going to be positive. If you've got a negative number minus a negative number, the answer is going to be negative. But when they're combined, you don't know because it depends on the starting number and it depends on the number that you're adding on, because it might pass 0 or it might not. So you can't always predict where we're going to end up. Right, now this very important rule. If you have an inequality, so in other words, you're solving something with a greater than or less than symbol in it, and you, for whatever reason, need to multiply or divide both sides by a negative number, then you need to remember to change the direction of the sign. I'll show you why that's true. If you take a numerical example like this, so 2 is greater than 1. That's obviously true. 2 is greater than 1. But then supposing I divided both sides by 1 or multiplied both sides by 1, then it would then say minus 2 is greater than minus 1. That's no longer true. Minus 2 is colder than minus 1 if we're talking about temperatures. It's further to the left along a number line. So if I multiply both sides by a negative number, with inequalities, it makes a statement that's not true. So I need to remember to flip the symbol around like that. So this sign, like this, needs to become this way round. -2 is less than -1. And as long as you remember that, you can use divide. I mean, it might be better to say that when you're solving inequalities, try to avoid multiplying or dividing both sides by a negative number. But here's an example where you might need to. So supposing we're trying to find the value of x, and we've got that 9 take away x is greater than 7. So probably the first thing you might want to do, well, there's two ways to solve this. I'll show you two different ways. So here's method one, would be to remove the -x by collecting the unknowns to the right hand side. So that's a little bit algebraic gibberish for add x to both sides. So I get rid of the -x by adding x to both sides. That's one way of doing it. So if we add x to both sides, then we end up with just 9 on the left hand side and 7 plus x on the right hand side. And then if we subtract 7 from both sides, then we get the x on its own. This says 2 is greater than x, but it also says x is less than 2. So if we read it from left to right, it says 2 is bigger than x, but if we read it from right to left, it says x is smaller than 2 or less than 2. So if we then swap that around, because we always want the unknown on the left hand side when we're giving our solution, we would just write it as x is less than 2. So that's the answer. So that's one way of doing it. Remember, if we swap it around, we've got to swap the sign in the middle. Another way of doing it is to divide both sides by a negative number and flip the symbol. So we would still start by subtracting 9 from both sides to get the x on its own. Remember, the -x stays as a -x, the minus sign doesn't disappear, but if we subtract 9 from both sides, we would have -x is greater than 7 take away 9 is -2, like that. So -x is greater than -2. And now the only way to get x on its own is to divide both sides by -1. But because I'm dividing by a negative number, I need to change the direction of the sign. So this sign like this is going to become this sign like this. And then divide both sides by -1. Or multiply both sides by -1, same thing. So x is less than 2. We get the same answer. Just use whichever method you find easiest. And fingers crossed, if you're doing foundation tier, you won't come across a problem like this. But it's better you know that rule just in case. Okay, here's one more example. 37 minus 12x is less than or equal to 1. So let's try the first method. So the first method is to add 12x to both sides so that we get rid of the minus sign in front. If we add 12x to both sides, we get 37 on the left-hand side. 37 is less than or equal to 1 plus 12x, like that. That should be quite easy. We just take away 1 from both sides. Happy with that? This will take a lot of practice. Take away 1 from both sides. 37 take away 1 is 36. And then we've just got the 12x on its own, which is what we wanted. Then to get x on its own, we divide both sides by 12. So divide both sides by 12. 36 divided by 12 is 3. So x is greater than or equal to 3, reading it that way. X is greater than or equal to 3. When they teach us in primary school, they talk about crocodile jaws, so wherever the jaws are open, that's the bigger number. If you read it the other way, 3 is less than or equal to x, so if we put the x first, we need to swap the sign in the middle, like that. So x is greater than or equal to 3. You can try some different values in the opening statement just to check that that's true. Happy with that? Let's have a look at method 2, where we multiply by a negative number and flip the sign. You might find this slightly easier, it's just that you've got to remember to flip the sign. So what we would do in this method is that we would start by subtracting 37 from both sides, so that we've got minus 12x on its own on the left hand side. What's 1 take away 37? So we start with 1, we subtract 37, that will give us minus 36. And remember, this minus sign stays stuck in front of the 12x. The sign always is the sign in front of the term, like that. So we've got minus 12x less than or equal to minus 36. And then to get the x on its own, we need to divide both sides by minus 12. Because we're dividing by a negative number, we will have to change the direction of the sign. So dividing both sides by minus 12, minus 36, divided by minus 12, you should know that 3 times 12 is 36. That will give me x. Change the direction of the symbol. So x is greater than or equal chapter 3. Are you happy with that? There's plenty of practice questions in your book. If you want even more practice questions, let me know. So if you run out of questions in the book, let me know and I can send you some more worksheets. There's some good videos on Hegarty Maths. I'll give you the links. So if you want to see some more, I didn't go through very many examples for some of these. So if you want to see some more examples being worked out, have a look at these videos. If you haven't got the chat box open, make sure it's open, then click on those links. Whoops, just pasted in the wrong thing there, sorry. Hegarty Maths videos, here they are. And I just gave you links to the textbook again. It's been a long day, I know, and it's only 1:30. So make sure you create a Hegarty Maths account and then just log in when you click on those links, and then those videos will open up. So there's some videos for inequalities, solving linear equations, and the revision videos will go through some examples of the types of questions that might come up in the exam, and then we've got solving equations with X on both sides. Do some practice questions from the book as much as you're able to. If you're having problems with any of the questions, just ask me or your tutor for help. If you've got the CGP book, the pages you want are page 27 for equations. Leave out simultaneous equations and quadratic equations, we'll do them later on, and inequalities, page 34. Maths Genie, as always, has got some really good revision sheets filled with exam-style questions, so make sure that you work through this at regular intervals. And remember, they've also got video clips, so they've got a video for solving equations, they've got a video for solving equations with the unknown on both sides. These are both in the grade 3 section. Yeah. I'm sorry to have to rush it, but watch the Hegarty Maths videos because there's only so much I can go through in 1 hour. And then for grade 4, inequalities, forming and solving equations. These are videos, so watch those little video clips in there. This is in the grade 4 section. These are the practice sheets, and these are the written solutions. So go to Maths Genie and practice these. Really, all I can say for the solving equations and inequalities is just say practice, 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 practice. Do as many questions as you can, and you will get the hang of them. I mean, I know I make it look easy, but then I've been doing these, so I can do them in my sleep. And sometimes it's hard for me to appreciate how difficult they can be when you've not really done them before. But it's as long as you go through it step by step by step, and remember that each step you're just trying to get the letter on its own. And if you need any help with any of these, don't feel that it's an important part of the learning process to ask for help. So please do ask for help, and either myself or your tutor will be happy to show you how to do it. Quick question, Ahmed, you submit Unit 1 test. You got 43 out of 60. No, that's fine. 43 out of 60 is a good mark. Did it come up as a grade? You might have just been 2 marks short, I think, of a grade 3, so you probably got a grade 2 for it, so that's absolutely fine. What I would do is, if you can't print out the PDF for next time, is you could just handwrite the answers. Your tutor's got a copy of the printed test paper, so you could just handwrite your answers on a piece of paper, and then take a photo of your answers, and then send that to your tutor, and then they should be able to mark it. Yeah, you got a grade 2. That's fine. So you would know if you had failed, because I think you have to get above 30 out of 60 to pass the test. If you got 29 or less, then you would just do the test again. But your tutor would tell you when they were marking it that you would do the test again. So have a check. You should now see your Unit 2 materials, but if you're not seeing them, then let me know and I can investigate. Okay. Grade 2 for the first test is fine. Hopefully you'll do a little bit better on the next test and so on. And the idea is that you'll just work through the grades as you go through. If you're aiming for a grade 4, then you're halfway there. It's one way to think of it. Okay then, if you've got Mathsbuster, here's a link to it. So I've demonstrated Mathsbuster in the past. I think it's really, really good if you want lots of practice questions. But you do have to pay $12.99 for it. Ahmed, no. Why? You don't need to do it again. You only need to do it again if you get less than 30. So I mean, what you might want to do is correct the ones that you got wrong, and just use it as a learning exercise. So the test papers are just there for you to get some feedback from your tutor, and so we can see how you're getting on. But put it down to experience, and just try and do better on the next test paper when you do test paper 2. Okay then, so if you're using Mathsbuster, go to the equations section and there's loads of practice questions there. Do these two, solving equations, writing equations, and solving inequalities. Okay, so if you just want lots and lots of practice questions, buy a copy of this and that will cover everything you need to do, and it's got videos and worked examples and so on. Okay, now when we go on to Unit 3, I will cover quadratic equations and simultaneous equations in lessons 37 and 38. So as I said, these are new topics to foundation tier. They've always been in higher tier, so everyone has to do them. But you need to be really good, obviously, at the easier equations first before you can attempt these more difficult equations later on. So there will be more to come. But don't worry, we've still got plenty of time. And then next lesson, I'll be covering linear sequences. Linear just means sequences where the numbers go up by the same amount each time. So that will be lesson 24. If you're watching live, that will be on Thursday. So hopefully you can join me then. You can also watch the recorded versions if you want to. If you're impatient, you just want to go on to the next lesson straight away, you can do that. This is exactly the same specification as last year, so all of the lessons are just the same. So if you want to skip ahead and solve any of the future lessons, if you want to do simultaneous equations, quadratic equations straight away, download the study plan and you can just click straight through to that lesson or use the recordings at the bottom of the page. That's everything from me for today. I hope you've enjoyed that lesson. Does anyone have any questions before I let you go? Anything? When you do short division, it should be obvious by the context of the question. So in the exam, it won't say do this short division question. It will have something like a teacher buys 100 pencils and shares them out between 30 children, how many pencils do each children get? So it would depend on the context of the question, how you interpret the remainder, but it should be clear from the question how you would do that. If you want to be short, have a look at some of the foundation tier paper ones, because you only need to use short division if you're doing a non-calculator paper, and the only non-calculator paper is paper 1. So have a look at some of the foundation tier paper ones and you should see the style of questions that come up. So say 125 divided by 3. It just depends, as I said, so you could write it either way. Sometimes you might need to round down and it wouldn't make sense to have a fraction. For example, if it was talking about the number of people, you can't have 2/3 of a person. So with remainders, it really does just depend on the question, how the question is worded. Sometimes you might need to round down, sometimes you might need to round up, and sometimes you might want to write it as a fraction or a decimal. If it's just the question, it doesn't matter that the two answers are equivalent. So 2/3 is equivalent to 0.6 recurring. So both answers would be acceptable. So if it's the same number written in a different way, then you can write it either way. Does that answer the question? Okay. It depends on the context. So I couldn't really tell you unless you showed me the actual question. So you'd have to show me the question to see whether it would make sense to round down or round up. So sometimes you just need to think a little bit, and sometimes they'll accept either. So it really does just depend on the context of the question and the way that it's worded. Can't think of any question off my head, but if you want to send me in a question and you're not sure about whether you should round down or round up or how you should show the remainder, I can tell you if you show me the question. Does that make sense? So there's no rule that you should always round down or round up. It just depends is the answer. Depends on the way the question is worded and what it's asking you to do. Any more questions? Okay. If not, I'm happy to stay online after I stop the recording. Okay. If you've enjoyed this lesson, please do just take a few moments to leave me a review on Trustpilot. Be much appreciated. It's always good to share if you're finding this a good resource. Some people don't watch the online lessons, so it's good to tell people that they're good and that you're finding them helpful and enjoyable. It's quite a unique feature of our online course is having these online lessons. So if you're enjoying them, please do spread the word by putting a review on the Trustpilot website, and that would be much appreciated. Thank you very much. If you want to contact me, you can phone me, email me, you can contact your tutor as always through the contact your tutor page on your course. And do remember that you can pop questions on the forums as well. Because I work full-time here in the office, anything you put on those forums I'll answer quite quickly. And if it's something not to do with maths, you can contact Student Services on that number there. Hope you've enjoyed that lesson. Hope it wasn't too hard. As I said, it all just takes practice. But if there's anything I can help you with, please do let me know. Bye-bye.